Okay, Algebra 1 fans, and welcome to the notes for today. The topic, multiply a polynomial by a polynomial. And before we start, let me give you your joke of the day. What did the pony say when it had a sore throat? And the answer is, I apologize, I am a little hoarse. Okay, so starting this topic today, we're going to finish up talking about polynomials and multiplying and dividing and all this stuff. And the last topic is what happens when you multiply a polynomial by a polynomial. So to start, part 1, review multiplying a polynomial by a monomial. So multiply 2x times x squared minus 3. This is a review. This is what we did last class. And I have to apologize again, there's a jackhammer outside the window. So 2x times x squared minus 3. 2x times x squared. Well, we're going to distribute. So we get 2x, add the exponents, you get 2x to the third. And then this is 2x times negative 3. A positive times a negative is minus 6x. And that's all you can do. You can't combine any like terms because the exponents are different. Now in the second example, multiply 5xy to the third times x squared y to the fourth plus 2xy minus 3x. Take it step by step. So you got 5. Multiply the x's, so you add the exponents. That's x to the 1 plus 2 is 3. And then this is y to the 3 plus 4, which is 7. That's 5x to the third, y to the 7. Plus 5 times 2 is 10. X to the 1 times x to the 1 is x to the second. Y to the third times y to the first. Add the exponents, you get y to the fourth. And then the last piece here is 5xy to the third times negative 3x. So 5 times negative 3 is minus 15. That's x to the first. X to the first times x to the first is x to the second. And then y to the third just stays like it is. Okay, so this is what we did in the last class. Distribute, and when you multiply, you have to add the exponents to the variables. Multiply the coefficients, but you have to add the exponents. All right, now, what happens though with a problem like this one? It says multiply x plus 2 times x plus 3. So we're going to multiply these two binomials. Well, you've got two choices. The first one is you can distribute, or what I would call you double distribute. You have to distribute twice. Basically, each term in the first binomial, now remember binomial is two terms, so this x has to multiply x plus 3. Okay, this x is going to multiply this binomial and this 2. So also, the positive 2 here is going to have to multiply, here I'll do it underneath here, is going to have to multiply x plus 3. So we'll say plus 2 times parentheses x plus 3. So basically both of the terms in the first parentheses have to multiply both of the terms in the second one. Okay, so we distribute. Well, x times x is x squared. X times 3 is positive 3x. 2 times x is 2x. And then 2 times 3 is 6. Now, can you combine any like terms? You have positive 3x and positive 2x. You can put those together. You can add those. So you get x squared plus 5x plus 6. 3 plus 2 is 5x plus 6. Okay? Let's actually go down. I'm going to show you the second method in a moment. Let's do this next problem beneath. And let's do double distribute again. 2x plus 1 times 3x minus 5. Okay, I'm going to write it down over here. 2x plus 1 times 3x minus 5. All right, so what's the process? Well, when you distribute, everything in the first parentheses, so 2x, has to multiply both of these terms. So I'm going to write down 2x times 3x minus 5. And then also, you have to take the 1 times both of these. So that's plus 1 times 3x minus 5. And now we work it out. 2x times 3x is 6x to the second. Add the exponents. 2x times negative 5 is minus 10x. 1 times 3x is 3x. And then 1 times negative 5 is negative 5. Now the last question though, is there anything that you can combine? How about it, the middle terms, negative 10x plus 3x? Okay, so our answer, 6x squared, that doesn't change. Negative 10x plus 3x is minus 7x. Negative 10 plus 3 is negative 7x, don't forget that term, and then minus 5. And that's all we can do. Now you might be saying, you know, I don't like all these parentheses, I don't like drawing all these arcs. Is there a better way to visualize this so that I don't forget something? And the answer to that is yes. And it's called the box method. Now I'm going to go back to the first problem here. I'm going to set up a box. And I'm going to put 4 squares in this box. And the reason I'm going to put 4 squares is that the outside of the box is where I'm going to put my binomials. I'm going to say x plus 2. That was the first binomial, x plus 2, and then times x plus 3. I'm going to put that in the top. I'm going to think of this as an area problem. How do you find the area of something? Well, you do, for a rectangle, you do length times width. So this is kind of like a times table, actually. I'm going to fill in this first square. How do I get it? Well, I do the length and the width, which is x times x. X times x, add the exponents, remember, is x to the second. How do I get this square? I do x times 3. You see where they meet? X times 3, it's like a times table, so that's positive 3x. Now this is 2 times x for this bottom square, so that's positive 2x. Now the last square is 2 times 3. Remember, this is times. We're multiplying. 2 times 3 is 6. So you get 4 terms in your box. Now notice that these 4 terms are the exact same terms you get when you double distribute. All right, so it's the same method, it just looks different. The last part of this though, so your answer is these 4 terms. But before we write it out, you have to ask, is there anything to combine? Positive 2x, positive 3x. You can add those. Once you multiply, so you multiply to get the squares. Once you have the squares, can you add or subtract? And the answer in this case is yes. You get x squared. We always put the x squared term first. Combine like terms. Positive 2 plus 3 is positive 5x, and then plus 6 is the constant. And that's it. That is the box method. Okay, let's try it for the second problem. So what am I going to do? I'm going to draw a box. And I'm going to label the outside of the box with my binomials. So the first binomial was 2x plus 1. So there's 2x plus 1. Notice that I put the plus term next to this constant. Okay, I'm not going to put it, in between my numbers. I'm going to put it right next to it. And then the other term was 3x minus 5. So across the top, there's 3x. Subtract 5. And again, I'm going to put the minus or the plus next to the constant so I don't forget about it. Okay, step 2, multiply. Right? You're doing area like a times table. 2x times 3x. 2 times 3 is 6. X times x. Remember, you keep the variable, add the exponents, x squared. 2x times negative 5 is negative 10x. Now, let's see, this square is 1 times 3x. Well, 1 times anything is just the thing back, so it's positive 3x. And I do put a plus sign there to remind me it's positive. And then we have 1 times negative 5, which is negative 5. After you multiply, now the question is, can you add or subtract anything? Can you combine? Yes. 3x minus 10x. This is like a diagonal, what we would call a diagonal in geometry. So it's kind of slanted like this. You get 6x squared. 3 minus 10. 3x minus 10x is negative 7x. And then minus 5. That's our answer. Notice that you get the same thing that you get from double distributing. It doesn't matter which method you use. You use the one that's going to get you the right answer, whatever you're more comfortable with. What I would do today, though, is I would practice with both and see if one method is better for you than another one. I like the box because it's visual. But some people like distributing, double distributing. Maybe it's a little bit quicker. I don't know. All right, let's look at these examples at the bottom. And for now, don't worry about what this is called FOIL. This is another way of double distributing, first, outside, inside, last. Don't worry about that. We're going to just skip that. We're going to work the examples. So let's take number 1 here. Multiply x plus 4 times x plus 2. Let's distribute this one. Let's do double distributing. So this first x has to multiply the binomial x plus 2. So x times x plus 2. And then the second value, 4, that's a positive 4, also has to multiply x plus 2. Now you might be asking, do I need to write this down? And the answer is no. You don't have to, but again, the idea is to get the problem right. To get the problem right, you need to avoid careless mistakes. I like to write this down so that I'm not mixing up my terms. Now we distribute. So we do x times x, x squared. X times 2 is 2x. 4 times x is 4x. 4 times 2 is 8. After you do this a few times, the process gets very easy. You'll go through it quickly. What can you combine? Positive 2x, positive 4x. So we get x squared plus 6x plus 8. And that's good. There's nothing else to combine. By the way, this is called a trinomial. 3 terms, you get a trinomial. These are both binomials. So we're doing a binomial. We're doing a binomial times another binomial. And usually, not always, but usually that gives you a trinomial. Okay, number 2. Multiply x minus 3 times x minus 4. Well, I'm going to use a box. I'm going to do this with the box method. So draw your squares, 4 squares. We have x minus 3. Again, I put the minus next to the number, and we have x minus 4. Now what's the process? You're multiplying. So the first square is x times x. That's x to the second. Now the next square, I go across. That's going to be x times negative 4. Well, that's negative 4x. And then we're going to do the square at the bottom is negative 3 times x minus 3x. And then the last square is negative 3 times negative 4. If you're going to make a mistake, this is usually where it would be. You are multiplying these. You are not adding them or subtracting them. A negative times a negative is positive 12. All right, question. Can we combine anything? Yes, we can. Negative 3x times negative 4, or excuse me, negative 3x plus negative 4x. So we get x squared. Negative 3 plus negative 4 is negative 7x. Don't forget the x, plus 12. And what we'll do is negative 7x plus 12. So flip it onto the back and we'll do a few more examples.